Welcome to my channel. In this video, we are going to learn Class 6 Mathematics, Chapter 5, GCD and LCM in a simple and easy step-by-step with explanation. Let's start. Chapter 5, GCD and LCM. Points remember, divisor or factor. A number that divides another number and leaves no remainder is called a divisor or a factor. A number that divides another number and leaves no remainder is called a divisor or a factor. Example, 5 is a divisor of 20. 5 is a divisor of 20 because 20 divided 5 equal to 4. Divides equally with no remainder. Multiple or dividend. A number that leaves no remainder when divided by another number is a multiple. A number that leaves no remainder when divided by another number is a multiple. Example, 20 is multiple of 5. 20 is multiple of 5 because 5 into 4 20. It is the product of 5 and integer 4. Therefore 5 into 4 20. Here it is the product of 5, this one, and the integer is 4. Then find the prime factor of 60. Here horizontal arrangement, 60 equal to 2 into 2 into 3 into 5. 5 3 is 15, 15 30, 30 to 60. Then vertical arrangement, 2 30 60, 2 15 30, 3 5 15 and 5 1 5. So here 2 2 3 5. So prime factors of 60 is 2 3 5. This set 5.1. Question 1. Write each number as product of prime factors. Question 1. Write each number as product of prime factor. Number 1, 69. Here 3 2s are 6, 3 3s are 9. So this 3 into 23. Then 27. 3 3s are 9, 9 3s are 27. So this one. Then 78. 2 into 2 3s are 6, 1 2 3s are 2 9s are 18. Then 2 into 3 into 3. This one. Then number 4. 126. Here 2 into 2 6 are 12, 2 3s are 6. Then 2 into then 3. 3 2s are 6 and 3 1s are 3. Then 2 into 3 into 3, 3 7 21. The factor of 127 is 2337. To write all divisors of each of the following numbers. First 18, divisor of 18 1, then 2, 3, 6, then 9 and then 18. So divisor of 18 are 1 2 3 6 9 18. Then 56, divisor of 56, first 1, then 2, then 4, 7, then 8, 14, 28 and last 56. Divisor of 56, 1 2 4 7 8 14 28 56. Then divisor of 120, first 1, then 2, 3, 4, then 5, 6, then 8, 10, then 12, 15, then 20, 24, 30, 40, 60 and last one 120. So divisor of 120, 1 2 3 4 5 6 8 10 12 15 20 24 30 40 60 120. (256) Divisor of 256, here 1, then 2, then 4, 8, 16, 32, 64, 128 and 256. divisor of 256 is 2, 1, 2, 4, 8, 16, 32, 64, 128, 256. Number 5, 67. 67 equal to 1 into 67. Thus, 67 is prime number itself. 67 is prime number itself. Then GCD. GCD means greatest common divisor. Two methods. Number 1, divisor method. In this method, list the divisors, then identify the common divisor, and then the greatest common divisor is the GCD. Number 1 method, divisor method. In this method, list the divisors, then identify the common divisor, and the greatest common divisor is the GCD. Second method, express each number as a product of prime factors and multiply the common factors. Second one, prime factorization method. Second method, prime factorization method. In this method, express each number as a product of prime factors and multiply the common factors. There are two methods in GCD. This set 5.2. Find the GCD of the following numbers. Find the GCD of the following numbers. Number 1, 36, 48. Answer, prime factorization method. Answer, first 38, 18 to 36, then this number 2 to 9, 18, then this number 2 into 2, 3 3s are 9, 2, 18, 36, 2 into 2 into 9, 36, 2 into 2 into 3 into 3, 36. Then second number 48. First 2 into 24, 24 2s are 48. Then this number 2 into 2 into 12, 12 2s are 24. Then this number 2 into 2 into 2 into 6. Then 6, 2 into 2 into 2, and 2 3s are 6. 3 2s are 6, 6 2s are 12, 12 4s are 48. Here common factor, here 2, here also 2, here 2, here also 2, then here 3, here 3. So common factor 2 2 3. So 2 into 2 into 3 equal to 3 to the 6, 12. Therefore, the GCD of 36 and 48 is 12. Here, how to check GCD 12? 12 3s are 36, 12 4s are 48. So two numbers are in table 12. Second, 31 and 2, prime factorization method. 31, 1 into 31, here 1 into 2. Your common factor, here 1, here also 1. So the GCD of 31 and 2 is 1. Next, 65, 13. Answer, prime factorization method. 65, first 5 into 13, 13 5s are 65. Here 1 into 13. The common factor, here 13, here also 13. Therefore, the GCD of 65 and 13 is 13. Then 108 and 132. Prime factorization method. 108. Then 2 into 2 5s are 10, 2 4s are 8. 2 into 2 into 2 2s are 4, 2 7s are 14. Then 2 into 2 into 3, 3 9s are 27. Then 2 into 2 into 3, this 3 into 3. Then 132, first 2, 2 6 are 12, 1, 2 6 are 12, 2 into 2, 2 3s are 6, 2 3s are 6, then 2 into 2 into 3 into 11. Then here common factor, 2 here, here 2, 2, here also 2, then here 3, here 3. Con factor 2 to 3. So con factor 2 to 3. Therefore GCD 2 into 2 into 3 equal to 3 to the 6, 6 to the 12. Therefore GCD of 108 and 132 is 12. 30, 24, 48. First 30. 2 into 15. 2 into 3 into 5. Then 24. 2 into 12. 2 into 2 into 6. Then 2 into 2 into 2 into 3 to the 6. Then last one 48. 2 into 24. 2 into 2 into 12. Then 2 into 2 into 2 into 6, 12. Then 2 into 2 into 2 into 2 into 3. Then con factor here 2, here 2 and here 2. Then con factor 3, here 3 and here also 3. So con factor 2, 3. So prime factors 2 and 3. Therefore GCD 2 into 3 equal to 6. Therefore the GCD of 30, 24, 48 is 6. And 2. The length and the breadth of room are 15 meters and 9 meters respectively. What the maximum length of each tile to be laid in square tiles in this room? Question repeat. The length and the breadth of a room are 15 meters and 9 meters respectively. What the maximum length of each tile to be laid in square tiles in this room? Answer. To find the maximum length of a square tile that fits perfectly along both dimensions, we need to calculate the GCD of 15 and 9. To find the maximum length of the square tile that fits perfectly along both dimensions, we need to calculate the GCD of 15 and 9. So divisor 15. So divisor 15 1, 3, 5 and 15. Then divisor 9 1, 3 and 9. Your con factor here 1, here also 1, here 3, here 3. So con factor 1 and 3. The GCD 1 into 3 equal to 3. Therefore the maximum length of each square tile should be 3 meters. The maximum length of each square tile should be 3 meters. Question 4. A garland seller has 48 red and 60 white roses. He wants to make separate garlands of both types of flowers. If the number of flowers in each garland is the same, then what is the maximum number of flowers in each garland? Here, question number 4. A garland seller has 48 red and 60 white roses. He wants to make separate garlands of both types of flowers. If the number of flowers in each garland is the same, then what is the maximum number of flowers in each garland? Answer. GCD of 48 and 60. Here 2 into 24, then 2 into 2 into 12, then 2 into 2 into 2 into 6, then 2 into 2 into 2 into 2 into 3, 3 to 6, 12, 24, 48. Then 60. Here 2 into 30, 2 into 2 into 15, then 2 into 3 5s are 15. So con factor here 2, here 2, 2, here 2, here 3, here 3, 2 to 3. The con factor prime factors are 2, 2 and 3. So GCD 2 into 2 into 3, 3 to the 6, 6 to 12. Therefore the maximum number of flowers in each garland is 12. The maximum number of flowers in each garland is 12. 1 factor 2 to 3 GCD 2 into 23 12. Year factor 4860. If you like this video, please like, share and subscribe my channel.